Welcome to our Week 6 presentation of Chapter 10, Enable Fast and Reliable Automated Testing. This is Group 4 with Garrett Hafen, Hector Ovalle, Mike Marshall, and Gwen Alphin. Every company should create quality product. It's done by developers doing automated tests to create faster feedback to fix problems. There are many ways to do that. A deployment pipeline increases the frequency of the automated testing from periodically to continuously. Continuous automated testing will trigger every time there is new code checked in. A deployment pipeline makes sure that the code is checked automatically in version control. This step is crucial because it enables developers to fix problems immediately and know where and what new code was integrated. Version control keeps a history of any changes. In my work, we use Git to control that. We can see who committed new changes, the time, date, etc. This has helped QA work with developers to fix any issues. There are many tools out there for version control, such as TFS, Git, Perforce, etc. It is important that the need agrees with which tools to use. Finally, the goal of the development pipeline is to provide feedback as soon as possible. This way, it does not pause the deployment process and makes sure it is fixed immediately. To produce quick and reliable results, we need our product to be tested thoroughly as it is being developed. In traditional build cycles, testing was done overnight or at the end of the waterfall cycle, so if there was a failure, it wasn't discovered till the next day or even when all the allocated hours were already used up and valuable time was taken up diagnosing and fixing the issue. We will cover some tips that can help speed up your testing and development cycles to ensure quick deliverables. Automated testing is becoming more and more important as products get larger, teams get smaller, and deadlines come quicker. Computers can do much of the heavy lifting of testing new and existing code, and automated tests do not eat up manpower to run. If we can write our automated tests along with or even before we write our code, then we can have almost immediate test results after pushing code to our testing environment. By writing the tests along with the code, you ensure that the test is comprehensive to the code you're writing, and it makes sure that the test gets written. Developers who write their tests at the time they write their code understand the code better than if they try to come back at a later time to write the test separately. This also enables us to test the code as soon as we are done writing it. Elizabeth Hendrickson observed, "Although testing can be automated, creating quality cannot. To have humans executing tests that should be automated is a waste of human potential. Much of what gets manually tested can be automated, which frees up individuals to work on higher priorities. This can include developing additional tasks or performing important exploratory testing which can't be automated." Most problems that arise right after a product is launched to production stem from performance issues. Too many actions or under-optimized queries, among other issues, can be hard to test or detect until the product is fully released. However, if we integrate performance testing, we can test multiple actions running in parallel processes to simulate the full load after release. With automated testing, we can simulate thousands of tasks at the same time, if not more, to ensure the product will remain stable after release. Non-functional requirements often get overlooked when testing an application because there is often no task or deadline associated with them. For example, how do certain words look in different languages, and do they fit in the set container? This example won't pertain to all projects, but it is that line of thinking that is the point of integrating non-functional requirements in your testing. An ANDON cord is the principal tool used to notify management and other workers of a quality or process problem. This can be a physical cord or button that is pressed by the worker or activated automatically by the production equipment itself. As illustrated above, when we have a vehicle on the assembly line missing a wheel, this is noticed by a worker who then pulls the andon cord, halting the production line, and a supervisor comes over to find out what is wrong. This allows the problem to be addressed quickly, and the assembly line can resume once again. In conclusion, Chapter 10 focuses on how we can create a set of comprehensive tests to confirm we have a passing and deployable build. The following tests were discussed: creating a deployment pipeline, automating our testing where possible, ensure testing is quick and efficient, creating a culture of doing whatever it takes to get production resumable again, and finally catching mistakes and errors early and fixing them right away. Thank you for watching our presentation.